In paramagnetic material, the paramagnetic values, when psi is positive, then all these materials are paramagnetic materials. In this, the value of psi is 10 to the power 5, 10 to the power minus 5, and same will be the value of mu r, because you know mu r is equal to 1 plus psi. Okay, so that is to the range of 10 to the power minus 5. Okay, now it is observed that this is changing with respect to temperature. When the temperature increase or decrease, this value changes. That means magnetization changes. And there was a law given by Pierre Curie speaking about magnetization of a material with respect to temperature. This says that magnetization of a paramagnetic material is related to temperature by this equation. This is what magnetic field B naught. C is Curie's constant for this equation. So M is equal to C B naught upon T, and here magnetization and temperature are inversely proportionate to each other. That means if temperature is lowered, then magnetization will increase. If temperature is lowered, the magnetization increase in paramagnetic substances. We can understand the reason for this. If there is material, it has got many dipoles, weak dipoles, magnetic dipoles, which are the cause of paramagnetic material, because there are certain dipoles present in this which are made by the combinations of many atoms and their magnetic fields. This we have discussed in paramagnetic lecture. Now, this percentage of these atoms which are aligned in a particular direction, there is a small percentage. Why others are not in this direction? Because they are moving in, they are rotating or they are moving this way, this way. So there is lot of movement in the atoms, and because of lot of movements in the atom, their direction is not aligned. Sometimes they turn like this, they turn like this, and this motion is there. Why this motion is there? Because they have got energy. What type of energy is that? That is thermal energy. So due to thermal energy, they are always in motion, and because they are in motion, they cannot align. They do not align. Now suppose I take this energy down. How? Lower the temperature. If you lower the temperature, energy become less. All the time, these magnetic effect, magnetic say magnetization is trying to align all of them, but due to temperature they were turning, they were moving. Now if the temperature is decreased, their energy of disturbance, that is decreased, and now they will align more. So less temperature, less energy of the at random motion. If less is at random motion, then more is alignment in a particular direction, and that is direction of magnetic dipole. So magnetic dipole increase. If magnetic dipole increase, the paramagnetic effect increase, that is magnetization increase. So this was drawn in a law, and that was Pierre Curie's law. If temperature is lowered, the magnetization increase. Now, if we do the necessary derivations, putting the values in terms of psi and mu naught, we get this equation. That is from this equation itself. So psi increase with lowering of temperature. That means lower is the temperature, more is the paramagnetism. If we keep on lowering, magnetization will keep on increasing up to what level? Answer: one situation will come when all the dipoles have aligned themselves. All. After that, if we decrease the temperature, there is no more dipole to align. So, paramagnetic property or the magnetization will not increase any further. That can be termed as limit of Curie's law. Limit of Curie's law. This is limit of Curie's law. We have already discussed it. So, remember Curie's law, when we use the word law, it is related to paramagnetism. Another thing will come, Curie's temperature, that we will study in ferromagnetism, and you should not get confused out of the two. So, remember paramagnetics, Curie's law in paramagnetic. So,